All right, students, here we're going to go changing a repeating decimal to a fraction. The example I'm going to use is this one, just since I already have it. Let's find out what it equals as a fraction. This is the stuff where I'm going to start out calling it like x. So this is what x equals. Let's find out what x equals, or what this equals. The next step is we're going to multiply both sides by something so that we can subtract the extra away. If I multiply both sides by 10, I'd get 10x on this side, and multiplying it by 10 would mean I'd have a dot between the 1 and the 6. So it'd be 1.6, and it looks like 6's go on forever. So 6's go on forever. 6 is forever. 6 is forever. If you remember this stuff, and you've seen it before, the next thing we are going to do is subtract. This side is equal to this side is equal to this side, because we multiplied it by 10 on this side and by 10 on this side. We didn't really change anything. It's okay to multiply both sides by 10 according to the commutative property. So I'm going to subtract both sides. 10x take away 1x is 9x. I hope I'm not going too fast. 1 minus nothing. 6 minus 1, and then all the 6's on forever and ever and ever and ever and ever and ever ever all would end up being zeros, and I don't need to write down all those zeros. They go away. So 9x equals 1.5. Next step is obviously to get rid of this times 9. So you get rid of times 9 by dividing by 9. If it's on the top and bottom, you can erase it. So x equals a 1.5 on top of a 9, but that's not the type of fraction that we should be looking for. I want to get rid of decimals with fractions. So let's multiply both sides, or the top and bottom, by 10. By 10 to try to get rid of the decimal. That would give me 15 over 90. Then the next thing I want to do is simplify that. You could do 5, or you could do 3. Let's take the long way and go with the small little 3. 3 goes into this 5 times. 3 goes into this 30 times. And then let's divide it one more time by 5. 5 can go into 5 one time. 5 can go into 36 times. So x equals 1/6. X equals 1/6. And x was 1600ths with the 6 repeating. So 1/6 is 1600ths with the 6 repeating. We can use this same video in principle to solve other repeating decimals. You just, instead of timesing by 10 on both sides sometimes, you might need to multiply by 100 on both sides, or 1,000 on both sides. The point is just that you can get the repeating parts to line up to be the same number on top of each other so that they subtract away for infinity. All right, you might need to watch this video a few times, or pause this right now and write it down as a note. Good luck.